Right now, you flip a light switch and a room instantly fills with light. You charge your phone without thinking about it. You plug something into a wall, press a button, and somehow invisible energy starts moving through wires. It feels completely normal. But electricity is one of the strangest things humans ever learned to control. People were experimenting with electrical effects thousands of years before they understood what electricity actually was. It is older than modern science, older than computers, and older than almost every machine you use today. So how did humans go from rubbing a piece of amber on animal fur to building a world powered by invisible energy? The story starts long before anyone had a light bulb. Around 600 BCE, in ancient Greece, a philosopher named Thales of Miletus noticed something strange. When amber was rubbed with fur, the amber could attract tiny pieces of dust, straw, or other lightweight objects. That sounds almost ridiculous today. Rub a rock. Watch it pick up some dust. But imagine seeing that for the first time. There were no electrical wires, no batteries, no laboratories, no concept of electrons. Just a piece of amber behaving as if it had suddenly developed an invisible force. Thales didn't know about electricity. Nobody did. But he had stumbled onto static electricity. And here's the important part. Humans had discovered the effect long before they understood the cause. That pattern would repeat for centuries. People would see something strange first. Then, much later, someone would figure out why. But the ancient Greeks weren't building electrical machines. For thousands of years, electricity remained mostly a curiosity. Then, humans started noticing something much more dramatic. Lightning. A massive flash crosses the sky. Thunder follows. Trees catch fire. Animals panic. To ancient people, lightning wasn't just a scientific phenomenon. It was terrifying. And humans eventually learned something incredible. The tiny spark produced by rubbing amber was connected, in a very distant way, to the enormous electrical forces in storms. Think about that. The little spark on your fingertip and a lightning bolt are part of the same physical world, but humanity still had no way to control electricity. Not yet. For centuries, strange electrical devices and stories appeared. One famous example is the so-called Baghdad battery, a small ancient vessel discovered near Baghdad and often dated to roughly the 1st centuries BCE or CE. Some researchers have suggested that, when filled with an acidic liquid, it could produce a small electrical voltage. Sounds amazing. But there's a problem. We don't actually know that it was a battery. Its original purpose remains uncertain, and there is no solid evidence that ancient people used it to generate electricity. So this is one of those fascinating historical mysteries where the honest answer is maybe. And that's important because the real electrical revolution didn't begin with an ancient battery. It began when people finally started treating electricity as something that could be systematically studied. In 1600, an English physician named William Gilbert published a major work on magnetism and electrical effects. Gilbert experimented with materials that could attract lightweight objects after being rubbed. He even introduced the term electric from the Greek word associated with amber. For the first time, electricity was becoming something worth investigating scientifically. But there was still a huge problem. Scientists could create tiny electrical effects. They couldn't produce electricity continuously. You could rub something. You could make a spark. Then, nothing. There was no electrical supply, no outlet, no battery, no way to keep the experiment going. And that limitation mattered enormously. Because if you can't produce electricity reliably, you can't really do much with it. Then, in the 18th century, everything started changing. In 1745 and 1746, European scientists developed the Leyden jar. It was one of the earliest devices capable of storing substantial amounts of electrical charge. Basically, humans had finally built something that could hold electricity long enough to release it later. And suddenly, scientists could produce much more dramatic shocks and sparks. Electricity wasn't just something that happened when you rubbed amber anymore. You could collect it, store it, release it. That changed everything. And then came one of the most famous experiments in scientific history. Benjamin Franklin wanted to understand lightning. In 1752, he famously proposed that lightning was electrical and suggested an experiment involving a kite during a thunderstorm. The popular version of the story makes it sound like Franklin casually flew a kite into a storm and waited for lightning to strike it. Please don't try this. Seriously. Franklin's actual experiment was designed to detect electrical charge from the storm rather than directly attracting a lightning strike. The experiment demonstrated that thunderstorms could produce electrical effects. Lightning wasn't magic, it was electricity. And now humans knew that the mysterious force in the sky was connected to the tiny sparks produced in laboratories. But here's the problem. Scientists could generate static electricity. They could store it. They could create spectacular sparks. But they still couldn't produce a steady flow. Imagine discovering water, but only being able to collect a few drops at a time. That's basically where electricity was. Then, near the end of the 18th century, an argument between two Italian scientists helped push the story forward. Luigi Galvani was experimenting with frog legs when he noticed something bizarre. Electrical effects caused the muscles of dead frogs to twitch. Galvani believed he was seeing a kind of electricity associated with animals. Another scientist, Alessandro Volta, disagreed. Volta suspected the electricity came from the interaction between different metals. And instead of arguing forever, Volta built something. In 1800, he created the voltaic pile, the first practical chemical battery. Now humans could produce a continuous electrical current. That was the breakthrough. Not lightning, not static sparks, a steady flow. For the first time, scientists had electricity they could actually work with. And once humans had a controllable source, experiments exploded. Scientists could send current through wires. They could study chemical reactions. They could create magnetic effects. They could build increasingly complicated machines. Electricity was no longer a mysterious trick. It was becoming a technology. And then came a man who discovered something even bigger, Michael Faraday. In 1831, Faraday demonstrated electromagnetic induction. The basic idea was astonishingly simple. Move a magnet near a wire, and you can produce an electric current. That meant electricity could be generated from motion. And suddenly, the entire problem changed. You didn't need to store all your electricity in batteries. You could generate it, turn mechanical energy into electrical energy. And that principle became the foundation of electric generators. Here's what makes this so important. Faraday wasn't just discovering another strange electrical effect. He had uncovered the basic principle behind the machines that would eventually power cities, factories, trains, homes, modern civilization. The electrical age was beginning. By the late 19th century, inventors were racing to turn these discoveries into practical systems. Thomas Edison developed commercially practical incandescent lighting systems and worked on electrical distribution. Nikola Tesla developed alternating current technologies and motors that helped make large-scale electrical transmission practical. George Westinghouse supported the development and commercialization of alternating current systems. And suddenly, electricity escaped the laboratory. It entered the city. In 1882, Edison's Pearl Street station began supplying electricity to customers in Lower Manhattan. Now, electricity wasn't just something scientists experimented with. It was something ordinary people could buy. That changed daily life. Before widespread electric lighting, darkness controlled the schedule. Sunset mattered. Candles mattered. Oil lamps mattered. Night meant fewer activities. Electricity changed that relationship almost completely. You could illuminate a street, run a machine, power a factory, communicate over enormous distances, and eventually power the entire digital world. But here's the strange part. The electricity itself never became visible. You still can't look at electrons moving through a wire and watch them like water flowing through a pipe. You see what electricity does. The light, the heat, the motion, the sound, the information. But the underlying phenomenon remains invisible. Think about that. Humans built civilization around something they can't directly see. And it all began with a strange observation involving amber and fur. So here's the full picture. Around 600 BCE, Thales notices rubbed amber attracting small objects. Centuries pass, while humans observe electrical effects without understanding them. In the 1600s, William Gilbert begins studying electrical phenomena systematically. In the 1700s, the Leyden jar allows humans to store electrical charge. Benjamin Franklin demonstrates the electrical nature of thunderstorms. Then, in 1800, Alessandro Volta builds the first practical continuous source of electrical current. Faraday discovers electromagnetic induction. Generators become possible. Then inventors like Edison, Tesla, and Westinghouse help turn electrical science into an industrial system. And eventually, electricity moves from laboratories into homes, factories, streets, and finally into the tiny device you're probably holding right now. So the next time you plug in your phone, remember what you're actually looking at. You're using a technology that began with humans noticing a tiny piece of amber behaving strangely. A few thousand years of curiosity turned a mysterious spark into the invisible infrastructure of modern civilization. We didn't discover electricity in one dramatic moment. We noticed clues. We made mistakes. We argued. We tested ideas. And generation after generation, humans turned something mysterious into something useful. Maybe that's the most human part of the whole story. We see something we don't understand, and instead of walking away, we keep asking why. And sometimes, that question lights the entire world. If you enjoy stories about the strange discoveries that built the modern world, there are plenty more waiting to be uncovered.